So I have my IntelliJ open now, and we will implement our first read follow-up one, which is read reentrance, which states that if there is if the thread can acquire a read lock, after that, if it again requests for the read lock, and there are no other threads which are writing or created a write request, it should be allowed to get that new read lock again. Okay, so I've got my IntelliJ open, and so here, I have coded a new class also, which is called as JReadWriteLock read reentrant, and it implements this read lock interface. And as we have discussed before, that this has got 4 methods for locking and unlocking read write locks. So let's implement this now. So if we compare here with this the field members that we have as compared to the normal JReadWrite lock, we can see that we have got readers, writers, and write requests all as a counter, as an int. But here the slight difference I have made for this read reentrance is that I'm creating a map here for instead of readers. Previously it was int readers, but now I'm creating a map because the concept is very similar, right? That I will maintain a counter. So as we have discussed here in the reentrance logic is that it maintains an internal counter belonging to the lock. So what it means is that if a lock has been acquired by the current thread, it will create a counter here as the value and it should be allowed if the same thread is acquiring the same lock, we'll just increment the counter. The same logic as it has been implemented by the JVM. So let's try to mimic that same. First of all, I have got this. I need to get the current thread, which is called this lock read, because it's a synchronized method. It means that whenever the thread is like entering this, it has already acquired this synchronized lock on this object, and we want to get the reference of the current thread. So this is how we get the current thread. Okay, and after this, we will have a logic here is that I need to check a condition that whether we can grant read access or not. For that, on this particular calling thread. So we will go through this that how to implement this can grant read access. But let's write the skeleton of this method that if it cannot be grant the read access bit on the reentrance or whatever the logic that we are going to implement, in that case it has to wait. Only when it moves out, it means that now instead of incrementing this readers here as we did in the previous example, here we are maintaining a reading thread, right? A map object. So what I will do is that I will call this reading threads and I will just increment the counter on this lock, which is calling thread, it's 1 and integer.sum. Okay, so what it means is that if the lock has been granted, I mean, we are able to get the read access now for this thread, this calling thread. In that case, we are already having a cache or a map here. If this thread has already not acquired the lock, in that case, it will just have the value of 1, which means that this is the first time this calling thread is acquiring this read lock. And suppose if it has already acquired this read lock before, and it has again called the lock read, if we should allow the read reentrance, right? So that's why we will just increment it to, like, say, if it is already acquired as previous value was 1, second time it has called it, the new value would be 2. The third time it is called, the increment would be 3. So it means that this thread has called 3 times for the read lock, and that's why the value in this reading threads for this current thread is 3. So this is the logic for having the counter associated with each of the calling thread associated with that read lock. Now let's go to this can grant read access. Again, just based on this logic before, that if there are any writers or any write requests, then in that case we cannot allow the read lock. The same we have to apply here. So let's create the first logic that if writers are greater than 0, then return false. Okay, and if because we are also applying the read-write lock mechanism here. For example, if in this reading threads map, if the same thread is trying to acquire the same block again, it means that it will be having a presence here. It will containing this key, and whatever the values there, we just. So first of all, we need to check that whether this map is having this contains key calling thread. We are passing this calling thread here, and if it's there, then we have to return true. It means that this is just the reentrant call. The thread, this calling thread has already acquired this read lock, and this is the second or third time or more than one time. That's why it is already having a value in the reading threads map, right? And then finally, we have also need to check whether there are any write requests or not. Only when the write requests are, say, less than equal to 0, I'm creating the condition. It should be always like equal to 0. We can do equal to 0, but better to like put less than equal to 0, because there's a possibility that here, for example, in this case, when the lock write is being called and we have got this write request plus plus, and there are multiple threads which are trying to acquire it, and some of the threads proceed here, and the overscheduler has rescheduled it, and more than one time the write request has been called. So there is a possibility that there can be more, less than 0 is equal to or less than 0 for the write requests. That's why I have marked it as less than equal to 0. But I think in most of the cases, in our simple examples, we are creating not many threads, so equal equals 0 should be also good. So again, let's revise this, that what has been done. So first of all, for the read lock, because we want to make the read lock reentrant, we got this calling thread, and then we can we actually created a condition that when we can grant the read access or not, and otherwise not, it is going to wait. Whenever it is acquired to get the read lock, only then we are going to merge it into the reading threads. It means that we are going to start with 1 is the first time, or we have to increment the counter to more than 1 by 1. For the can grant read access is very simple, where we are actually checking the writers and the write requests. So that if the writers are greater than 0, it means that there is one thread which is writing it, and that's why we cannot grant the read access. Returns false. And if this is a second or third time or more than like one time, when the same thread has attempted to get the read lock, it should be having a presence in this reading threads map, and that's why it should return true. And otherwise, the last condition is that if there's any greater than 0 write requests, in that case also we cannot grant the read access. So this is about this, and so we have implemented our lock read. Now let's implement our unlock read. Unlock read is also quite similar to lock read. That first of all we get the calling thread by thread.current thread. After that, we actually want to see that whether the thread this reading threads map has already got an access count. We expect that at least it should be 1. At least because otherwise unlock read will be always called after we call the lock read, right? And that's why if a thread was granted the read lock, it should always have a presence in this reading threads map, at least 1, right? So this is what we're going to get it. And after this, if we have to check that if access count equal to 1, it means that it was only like one time it was called, and all other previous locks have been released. The reading threads is only having the value of 1. Counter is 1. In that case, we have to simply remove it, right? Because now we don't have any access further for this calling thread. We'll just simply remove it. Otherwise, we just decrement the counter to 1 from 1. This is the same behavior as we have discussed in this example, is that if there is a synchronized lock being called here, and it has got to do something again. So at this point, the counter would be 2. And then finally, when this do something, this lock has been released in the synchronized block, counter reduced to 1. And once it comes here, it further decreases to 0. When it's decreased to 0, it means that the thread has released this lock. The same thing we are implementing here. That if the access count is equal to 1, this is the last point at this. This is at this point. And then when it comes out of this point, it should be simply removed. There should be no access at 0 as well. So we have to simply remove this here. Now here in else, again, we can just simply put as calling thread and access count -1, right? And then we have to call notify all. So this is the simple implementation again, there where we are just removing the last. If this access count is 1, we are simply removing the calling thread from the map. Now for the lock write and read and unlock write, it would be quite similar as we have implemented here. So I'll quickly go through it. Now, again for the lock write, whenever this lock write is being called, we have to increment the write requests, of course. And then first of all, we'll get that how many readers are available in this map for this calling thread. So this is what we are doing, that the current thread, we get all the readers associated with it, because if it's present there, then it would be there are some readers there on this thread. So this thread has got the read lock before. So this is what it implicates. Okay, so now we have to check again the same condition as we have done before, that while there are any if the readers, I will, instead of this, I will use integer, so that I can actually check whether it's a null or not. Integer is not equal to null, and readers are greater than 0. If there are more readers, okay, so we have seen here that our previous implementation, that if there is writers or readers are also greater than 0, the lock write has to wait here. So similar thing we are doing here. We are first of all getting all those readers as an integer object, because we can check the null as well. And then we actually check whether readers are greater than 0, or, so this is the same, this condition is same as readers greater than 0 here, this one. It's the same thing we are putting here. Okay, so while readers and readers are greater than 0, let me make it better. Okay, so we have got readers not equal to null and readers are greater than 0. This is our first condition. Or if there's any other writer which is already holding this write lock, in that case it should also block here. In this scenario, we have to wait. And finally, if we are out of it, it means that we have to decrement this write request and then increment the writers plus plus. Okay, so again, this is the very same condition as we have done here, that this part, readers greater than 0, is implemented like this, that we are checking it from the cache, from the map itself, and other parts are exactly same. Similarly, the unlock write, this is also exactly same. We have got writers minus minus once we unlock it, and then notify all for all the threads which are waiting here.